your exam in class on Wednesday, I'm just about done making it. What I'm going to do, and I'm kind of weighting it kind of roughly equally across all three sections. The oddball is the intro. The intro to prob and stat section, that's kind of the oddball because center and spread shake hands so beautifully. I mean, they really do, if you think about it. The idea of when you have an average and then deviation from average. So you've got this intro to prob stat section. And then you got this center section. And then you got this variation section. And honestly, these two, any question on the exam that involves center is also going to involve standard deviation. I mean, they all do. It doesn't make any sense for me to ask one and not the other because they're tied together. So pretty much you can kind of treat these. That'll be like 2/3 of the exam or questions involved in that. The intro to prob stat, I kind of broke this one down. You had already done that quiz with the discrete, the qualitative, and the quantitative, and all that wonderful stuff. And you guys nailed that, so I didn't want to make this a vocabulary quiz. But there is one type of question I kind of like, and this is where I give you, give you a little statistical reading. Little blurb. Blurb. And I pulled it out of a little research journal I was traipsing through. And I asked you to go in and identify the sample, the population, the statistic that was gotten from the study, the margin of error on the statistic, and the parameter they're trying to estimate. All of that's given in the blurb, and your job is to go and grab that out, and I made it matching. So on one side of the paper, you've got parameter, statistic, margin of error, sample, population. On the other side, you've got the values from the article, and then your job is just to match them up. The parameters here, so it's not really a definition, it's an identification. And I hate testing on definitions, because that's like something you do in like 2nd grade. So just making sure that you can ID those things, a parameter, a statistic, a margin of error, what else did I say? A sample and a population, thank you. A sample and a population. And your job, like I said, is just to read the blurb, look below the blurb, and then kind of match up the pieces as they go. That's it. Because that's what I care about. I don't care that you could regurgitate back the definition of what a parameter is. I care that you can read something and understand what it is in there. That's what I care. Because if you can understand, if you can pull it out of a blurb, that means you understand the definition of it. So that's one thing I did. The other thing I did, I think you're going to have fun with this one. It was a National Geographic study that I found that had a huge chicken on it. And it was like, that's kind of cool. It's a big chicken, and a little tiny duck, and like a little tiny pig. And I was like, what the hell is this? And I was immediately interested in it. And it was the number of foods that the world eats. And it was scaled by the size of the animal in the graphic. And I was like, that's freaking cool. You know, the big chicken leg, this little tiny duck, and this little tiny fish. And I said, let's analyze that. Let's see if National Geographic did a good job presenting the data. So what I'm going to put, I'll tell you that's what you're going to be doing in class on Wednesday. But do you remember the problem or problems in your homework with the debt balloons? Remember the debt balloons? I'm just going to put quote unquote debt balloon type. It's kind of like that one. In that one, you discovered that whoever put that graphic out, which is hyperlinked on the homework sheet, kind of was kind of misleading in how they presented it because they made the balloons look too big compared to the debts. I want you to see if National Geographic made the exact same error. And because the chicken was just so large, I'm like, holy crap, it just pops out at me. So you'll be doing a little bit of kind of figuring based on that same kind of debt balloon. Yeah, I think I'll have fun with it. Cool? Those are the oddballs because they don't really, they tie in to this only by virtue of the fact that you are finding the center and the spread in kind of name only, if you will, over here. So it does tie in, but loosely, if you will, loosely. So, as far as center and variation, as long as you can find the mean and the median, the mode, and the standard deviation of both raw and grouped data, Everything will be fine. To quote Doc Brown, Back to the Future. As long as you hit the pole with the connecting hook, the moment the lightning strikes, exactly 88 miles per hour, everything will be fine. So as long as you can do that, and use your technology, not by hand. You're doing this with technology. You do have to do, sometimes you have, like for example, for group data, sometimes you have to do a little bit of manual computation before you use your technology. In particular, finding that middle value of the ranges.
Like saying if somebody was age 25 to 30 going 27.
You would go 27 and a half, exactly, Tim. That's the only thing you have to do. I mean, but yeah, and you can, if you really want to, make your TIs do that too if you wanted to. I can show you that at break if you want. But, so that's all. Cool, pretty straightforward. I make the out of class ones be a lot more why? What do you think? What do you think? How would you answer? I think the in class ones be like, give me the average. Give me the standard deviation. It's between this and this and this and this.
Because we're freaked out. We need something simple.
Well, I'm trying to alleviate the freaked outedness. Honestly, I am. One thing I hate is, because what happens when you guys freak out?
I can't do it.
You can't think. As soon as you start taking the exam, you can't think then. So even though you know the stuff, you can't demonstrate that you know the stuff. So I try to keep these much more straightforward, much more guidance on that. Like one of the questions in here, I'm probably going to include, you know, since the data is approximately bell-shaped, like instead of asking you, is the data bell-shaped? Since the data is approximately bell-shaped, roughly 95% of the data will be within 2 standard deviations. That is within blah, 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 blah. So I give you, rather than memorizing stuff, I'm giving you stuff. Can you then take what I've given you and do something with it? That's what I'm after. So I'm trying to alleviate some of that agita, Mary, that agita, because if I take the agita away, maybe you can actually do something, as opposed to being paralyzed with fear, which I don't want to. Hopefully I can alleviate that a little bit. Cool? Make sense? Any questions?
What did MOE stand for again?
Margin of error.
Thank
Great
you.
question, Danny. Margin of error, and that will be given to you in the report. Your job is just to know what to do with it. And think, when you think margin of error, think the exact same thing you do with standard deviation. You add and subtract it from the center. So you add and subtract that from your sample statistic. And I think, if I remember correctly, in case you need like a quick refresher of margin of error, definitely look back to the intro homework, but I also included some margin of error stuff in the variation homework. The last question, I think. It's a little bit dated. I think it's about like Gingrich running against Obama for the Democratic National Convention, but it doesn't matter if it's dated or not. It's still valid as far as the argument. Cool? I got some new data for you guys to play with over the weekend. Changed the brakes on my cyclocross bike from cantilevers to V-brakes. I wanted to see, I almost died a couple times with the cantilever brakes. Got any bikers in here? Cantilever brakes are terrifying. They went out of style in about 86 when they went out of style. For some reason, my 2012 GT bike came with cantilever brakes, and I've eaten it a number of times going down steep switchbacks. Brakes bottomed out, like I'm hauling on the brake levers, and I'm not slowing down. I'm like, well, I'm going to dump the bike and run over the handlebars. And after I bent my second derailleur hanger at 15 bucks a pop, I'm like, you know what? Let's spend 50 bucks and put some V brakes on. But I wanted to make sure that doing that was actually sensible. So what I did was I ran a test of my little cantilever brakes. I got myself into a free fall, top a very steep driveway. Let myself roll, had a tape measure stretched out. Then hit the bottom of the driveway and grabbed the brakes, and took how long it took me to go to a non-skid stop. Had my son help me with this, he was totally about it. It was 22, Daddy! So man, you know, I took 24 data points something, and I took those brakes off, put the V-brakes on, redid it with the V-brakes. It's 16, Daddy, it's 15, it's 14, it's 18, and we were getting 20s and 21s and 22s, we were getting 15s and 16s. I'm like, well, that's shorter.
Yeah.
That's shorter, and I almost crashed this morning coming into work. Only because they grabbed so tight so quickly. And I was coming so fast down this hill, and I was used to the old brakes, and I'm like, I'm almost at the building, I'm like half asleep, and I'm out of the pool, I'm exhausted, I'm swimming, and I'm coming down right by Juniper Hall, that hill by Juniper Hall, and it whips around by Grandview, and I'm like, here we go. So I come in, and usually with the cantilevers, I have to start braking now, and I'll stop by the time I get to the door, so I kind of leaned in, I'm kind of like zoning out. Grab the brakes, whoop! Back out of the bike comes up. And I'm like, let go! Drop it back down. I'm awake, no coffee needed this morning. FYI, when you brake on a bike, 80% of your braking power is on the front brake. FYI, careful. Any non-mountain bikers out there, I've seen many road bikers when they become mountain bikers, over the handlebars very easily because they think equal braking power. No, you need way less braking power on the front because 4 times as much force is applied on that front one. And keep your butt back if you're braking steeply. I learned that this morning too, even when I don't think I know what I'm doing. Why did I just tell you that? Oh, because I'm going to have you guys crunch that data later. I'm going to have you guys crunch that data later. Got some nice raw data for you to play with. So, cool? All right. Speaking of data,